Assalamu alaikum, everyone. I welcome you all in today's webinar on 3D printing concrete technology uh, from the BIMPAC platform. It's my pleasure to introduce our esteemed speaker for today's webinar, Dr. Syed Farasat Ali Shah. He's a distinguished postdoctoral fellow in Department of Civil and Environmental Engineering at Hong Kong Polytechnic University. He has a great academic and professional background. He has made significant contributions to the field of civil engineering, particularly in the areas of cement and concrete composites, alkali activated materials, and 3D concrete printing. His academic journey is marked by excellence, having completed his PhD in structural engineering from Shanghai Jiaotong University, where he received Chinese government scholarship. His research has been widely published with over 19 peer-reviewed journal articles and numerous conference proceedings. Today, Dr. Syed Farasat Ali Shah will share his experience on the transformative potential of 3D printing technology, 3D concrete printing technology. It is a topic which is very important for construction industry and has been a very important for increasing the productivity of the construction industry. We are very honored to have him with us in today's webinar. Without any further ado, I would like to invite Dr. Syed Farasat Ali Shah to start his webinar. Thank you so much.
Okay, I cannot hear you, but I think you can hear me. I can start the presentation, and in the meantime, I'll try to figure out why I cannot hear you people. But everything looks in order to me, but I don't know what seems to be the problem.
If there are any questions later on by the participants, they can ask in the chat and
I'll just start the presentation. Thank you, Dr. Wakas. I couldn't hear your introduction, but no problem. Good afternoon, everyone. It's a pleasure to be here today to discuss a topic that is not only close to my heart, but also pivotal to the future of construction, 3D concrete printing. As we gather here virtually, we are at the cusp of a technological revolution that promises to redefine how we think about building and construction. 3D concrete printing is more than just a novel technology. It's a transformative approach that offers new possibilities in design, efficiency, and sustainability. Today, I will take you through the journey of understanding what 3D concrete printing is, how it works, and the different ways it can be applied in construction industry. My focus will purely on construction industry and concrete printing. We will explore its benefits, challenges, and the exciting future it holds for the architects, engineers, and builders alike. I encourage you to think about the implications of this technology, not just in terms of technical capabilities, but also in terms how it can address some of the pressing challenges we face in construction today, such as reducing waste, improve safety, and enhancing design flexibility. I look forward to sharing insight from my research and experience. I'm eager to engage with your questions and thought. As we delve deeper into this fascinating subject. Now let's start with the presentation. This is a brief profile. I think Dr. Wakas would have already given a brief introduction, so I'll skip this slide. It shows my professional experience, which is around 17 years, and my research profile and contact info. Now I'll discuss the contents of the presentation. Contents of presentation includes industrial revolution. We'll touch upon the industrial revolution and how concrete industry is like not related to, not as modern as the other industries, and how it is a bit conservative in approach. Then we'll discuss about 3D concrete printing. We have two major classification. One is extrusion based and other is powder based. We will touch upon both of them. Then I'll show some of the applications of 3D concrete printing. Then rheological requirements, what are related. Okay. And okay. And okay, thanks, Dr. Vakas. I just saw your text because there was a few messages, so I just wanted to check that. No problem. I'll see in that. Okay, and then we'll discuss about the rheological requirements. And lastly, we'll touch upon two-stage printing. It's specifically for concrete because concrete material is quite different from the metals and the polymers. So two-stage printing is a modern way of controlling the rheology of concrete. Okay, now we'll talk about the industrial revolution. We all know about like three industrial revolutions and four in which we are today. First industrial revolution is the transition from agrarian and handicraft economies to industrial system driven by steam and water power. Previously, like before the industrial revolution, we used to do mostly the work was done by hand, but in 1700, with the invention of steam power and water power machinery, a lot of industries were created, especially like textile industry was boosted in these years, and world saw a big industrial revolution. The first in the second stage, with the invention of electricity and mass production lines, the world had shifted again to from the conventional steam powered machinery to electric power machinery and big assembly lines and production of steel, which eventually uh, formed in the automobile and chemical industry was also developed during this revolution. The third revolution is the latest one in 1900s, in which the computer technology was evolved, and because of the computer technology, digital revolution and electrical the was combined with the mechanical and sophisticated equipments, and now computer operated machineries are in use. And the fourth one, which is actually in focus now, it 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 is cyber and physical system, Internet of Things, which merges physical, digital, and biological worlds all together. In current industrial revolution, we try to mix the virtual world and the real world problem all together, and the 3D concrete printing is part of it. However, if you see, like, if you observe, most of the industries around the world are like very futuristic. Many machineries, many industries have like robots working in them. Like there are lots of systems which are already completely robotic. But when you compare it with the construction industry is still one of the most conservative industry. I have an example for you. Like you see, this is a picture of a structure which under construction structure in 1912, and this is the picture of an under construction structure right now in 2024. You can observe generally the overall structure of the building is same. We have the same kind of column beam structure. We use the same process. First we build the frames, and then we put the steel. And although we have some mechanical equipments, like we have the large scale cranes, we have some of the equipment for mixing the concrete and then placing it on top, but overall the construction pattern is almost same which used to be in like 1900s. So we can see that construction industry is not like very futuristic, and it is not uh, actually utilizing the upgradation, utilizing the new techniques. But Now the construction industry is like in is try to incorporate these new technologies. For this purpose, the most important aspect or the automation of the construction industry is possible with 3D concrete printing. What is 3D concrete printing? 3D concrete printing is a form of additive manufacturing used to fabricate building or construction component in completely new shapes, not previously possible using traditional form. Uh, if we try to define the 3D concrete printing, we have to define it like two basic, because it's a broader term, involves lots of methods, lots of applications. So we have to have a general definition, and for that form, we have like two major things for 3D concrete printing. One, it can fabricate in any shape. Like the advantage of 3D conventional concrete over the 3D concrete printing over the conventional system is that in conventional system we have to have a mold to prepare a shape. So it is not very cost effective to prepare any shape, because we have to have a mold for each and every shape to prepare that. So one of the most important aspect is that we can prepare concrete in any shape, and we don't need the use of formwork. That is one of the most important aspect. The second aspect is reduction in construction cost. Right now, it can be like a bit questionable because some of the technologies like 3D concrete printing technology is a bit expensive. So you can say that it is, maybe it's a questionable thing that construction cost is reduced. But generally, when the technology will evolve, and it is evolving rapidly, I'll show you some graphs about it, then the construction cost is bound to reduce, because the labor will be reduced and the quantity of the waste will be reduced. Because if you use the 3D concrete printing, you just have to uh, it's a robotic construction. You won't have lot of, you don't won't have any waste material. So if the labor cost is reduced and if the material cost is reduced or the wastage is reduced, obviously the construction will reduce. And also improve production of high quality elements. Like it's obvious, like if you prepare with the robot and if you prepare it manually, obviously the one which you use to prepare with the robot will have a perfect shape. And last but not the least, the time saving and increased productivity associated with 3D concrete printing. Okay, I'll talk about briefly about the history of 3D concrete printing. So, 3D concrete printing is a robotic printing. I'll show you in the upcoming slide, I'll show you the process. But if you try to digitalize or automate the construction, so you can go back in 1904, the first patent for bricklaying machine was granted to John Thompson of the US, in which an automated bricklaying machine was developed. In 1917, uh, there was a device prepared which used to take the concrete from in vertical plane, elevate in vertical plane. You have all seen these device. The second one, whenever you are doing construction in second floor or third floor, you need a lift to carry the concrete. So it was the lift for vertical plane movement was introduced by James McDonald, and it was published. This work was granted a patent in 1917. In 1981, layer by layer approach for polymer was introduced by a Japanese scientist, and it's not on the concrete, but the concept is was developed, which is layer by layer construction. And in 3D concrete printing, we also follow the layer by layer construction, layer by layer approach. So it is also an important step for the development of 3D concrete printing. In 1984, Chuck Hull developed another approach in which he developed SFS system. I'll discuss this system in detail, in which a powder is applied with the laser, and the laser hardens the material. and it can evolve any shape. And the modern method, which is called like contour crafting, it's the layer by layer construction, and it was developed by Behrouz Khushnavis, an Iranian guy in University of Southern California, and he is considered like the father of the modern 3D concrete printing. Also, Chuck Hull is also considered the father of printing, but if you talk about concrete printing for building construction, Khushnavis work is the most important and most early work which is related to construction of the buildings. Now we discuss slightly about the growth. So in 1998, the initial paper, initial work was done by Kushnavis, and then every year there is like exponential growth in the number of projects which are which use 3D concrete printing, and same is the case with the revenue, and the revenue is increasing day by day, and the 3D like when in 1998 it started, you can see that in the start, like 5 to 10 years, the growth is quite nominal. The growth is like not quite uh, visible. But from year 2010, the growth is quite exponential, and now throughout the world, people are adopting this technology, and lots of structures are using 3D concrete printing for construction of houses, buildings, bridges, so many stuff. Uh, Now, few pros and cons of the technology. Uh, we'll discuss with some pros. There are like, if you talk about the advantages, there are two major categories of advantages. One is like the faster construction, the advantage, the low cost advantage, geometric freedom, and the other portion is sustainability. Sustainability is the buzzword, in the in current world. We try to make the structure more and more sustainable and try to reduce the environmental pollution and all the negative impact for environment. 3D concrete printing is not only fast and effective, fast or low cost approach, it is also sustainable. Why it is sustainable? Because it produces less waste. It doesn't require any form work, so you don't need extra material to be used for like form work, the wood or the steel form works. Also, it's a bit safer inside because if the labor is reduced, obviously it is more safer, and it's socially advantageous. Like it has no social implications because it's just remote working and there is not much people involved. If we talk about the challenges, what are the challenges these associated with 3D concrete printing? First is like high initial investment. You might have known that I think in Pakistan only NUST has 3D concrete printing. I'm not sure some other university has or not. Generally, 3D concrete printing is a bit um, printer is quite costly, and even the construction industry or big construction companies are like not doing enough investment at this stage. And but obviously with the time, this cost will be reduced as technology grows. More people come into the field, and obviously the cost will be reduced. But at this stage, 3D concrete printers are a bit expensive. Secondly, specialized training. Obviously, with any new technology, you need the skilled workers, skilled people. With 3D concrete printing, it's the same problem because we don't have much skilled workers, and in the area is like quite new, and people are not used to how to operate the 3D concrete printers. Secondly, limited material options. We'll discuss this in detail because the material requirements for 3D concrete printing are quite strict. You need to have a flowable material, but at the same time, it should be buildable. That is, it should harden quickly. Hours after the extrusion, it should harden quickly that it can support the subsequent layers. So you need a very specific kind of material with specific properties. So they are also quite limited. Like you have to develop a material, or there are few companies. I have some data of the companies who provide the printable materials as well. Also, there are some regulatory uncertainties because construction industry is associated with huge amount of investment, and the people are affected. So you have to have regulations to of use. Everybody cannot use 3D concrete printing if the regulations are not there. Also, technology needs to be a bit improved, and the stakeholder trust. People are like nowadays people are more focused on using, but still there are lots of issues related to 3D content. Okay, we'll if I discuss about the process of 3D concrete printing, it's a small figure and a video to show the process, but what is the process actually for 3D concrete printing? Actually, first step is the mixing. And first step is the concrete mixing, and after the concrete mixing, we also have input data in form of a model in your computer. Any shape which you want to draw, you have to draw a CAD model using any software, which you can use any software like Tinkercad, Simplified 3D, Autodesk Fusion, SolidWorks, Sketch Pro, any software. You can get a CAD model, a 3D CAD model from this, and then convert it to STL model. It also depends upon the specific printer you are using, because every 3D printer has its own software, and it uses that approach to develop it. Sometimes you have to convert the 3D model in the model in the software, uh, in the printer software which you are using. After you have input the model and you have prepared the concrete, you have to put it in the extruder, and in layer by layer construction, it can be printed. It's a small video in which we can see the layer by layer construction. It's on gantry printer, in which I'll show you the gantry printer as well in next slides. You can see it. What it does is that it depends upon the nozzle and shape. You prepare a concrete and it is printed, and it is flowable, so it can be extruded out, and it has to be hardened enough that it can support the load of subsequent layer. So it is a layer by layer construction in which concrete is prepared in layers. I hope you can see the video and you understand the process. uh, okay, now I'll try to discuss about the major division of 3D concrete printings. What are the two main categories of 3D concrete printing? There are like two major approaches in which 3D concrete printing can be done. One is like extrusion-based printing, and other is powder-based printing. Powder-based printing is like not really for concrete. It can be used, but it is not like very suitable. It is generally for small structures. And also this technology is more suited for steel, metal printing. If you want to do polymer printing or metal printing of any specific shape or size with the detailed structure, you will follow powder-based printing. And if you want to prepare actual structure, a house, a bridge, any infrastructure, structure member, anything, so mostly like extrusion-based printing is applied. So, and now we'll discuss extrusion-based, but extrusion-based also has two systems. One is robotic arm printer, and other is gantry. I have pictures for both system. Gantry is like this. You have a complete frame of frame, and in this frame there is X and Y axis. So what happens is that on these the printer head moves along the axis of in X and Y direction. Whenever you will prepare a model and you have to give a starting point for it, And from that starting point, you will have to give the x and y coordinates. In the model, actually it calculates by itself, but it can only move in x and y direction. And it can, after layer by layer extrusion, it will move up step by step, but its major direction is like in x and y direction. This is called gantry type printer. Generally, gantry type printer can be of any size, because it's, you see, it's a complete frame, and the frame can be prepared of any size, and it is like much stable kind of structure, and it can be used to prepare bigger structure. But in a gantry type printer, the speed of extrusion is a bit slow, because it has to move across the frame. So it generally, its extrusion speed is not very high. And in case of robotic arm printer, which I have shown a picture for you, it can move in 6 axes, and this extrusion speed is generally very fast. All printers have these structure, like it has to be, there is a mixer here, there is a concrete pump. And concrete, when you firstly you have to mix the concrete, and after that you have to put it in the pump, and with the pump it will be a pressure will be applied, and it will go through the machine, and with the machine it will be extruded out, like I showed you in the video before. Robotic arm printer can move in all directions, and it can be used to prepare any shape. But in gantry, it is a access limited printer. So this is the basic difference. Uh, Generally, the 5 steps is: first step is the mixing, second step is the pumping. You have to put it. Third step is extruding, and fourth step is the building. I've already discussed, so I will not go with this. And now if you see, I'll again show you in this video how the extrusion printer work. You see, this is a fixed frame, and in fixed frame there are like rollers, and it moves across that plane, and it complete, because the model was already created before, and just you have to put uh, because this is from my own lab, and here we are not actually putting the concrete through pump. We are using uh, putting it manually, because last time it failed. So sometime it happens, so you can also do that. But generally it has to be connected with the pump, and the pump will you can see a small opening for the pump here in the middle. I'm not sure you have the printer. uh, you can see the mouse. This is for the pump, and with the pump you can blow in the concrete, and it will extrude it out here. So this is like the gantry system, and this is the robotic structure. It is also from our lab, and you can see the difference in this video. Generally, you can see the extrusion speed is very fast. I have the video is quite small, but all you can see the previous structure. Generally, the speed of the printing is very fast, and you can prepare any shape. You can see this column is quite a tilted kind of a column. You can prepare all different shapes in case of 3D robotic arm printer. Okay, now the second form is like powder-based printing. I'm not sure many of you will be familiar with this kind of a printing, but it is also quite common form of printing. In this printer system, what is done, it's like a powder bed is created, and powder bed is infused with either the laser or with the binder jet. Both can be used. It depends upon which material you are using and what is the purpose of your uh, uh, production. Generally, laser sintering is done for like metals or polymers, and like selective absorption technique, in which a binder bed is created, and then on top of it, with the temperature or without temperature, a binder is flown, and it forms the shape which you want. I have, this is steps for this. So first step is model creation, whichever model you want to create. And the second step is you pour the powder in the machine. It's all powder. And after the powder is poured in the machine, then the printer is turned on. This video is quite fast, but actually the printer, because the model is already saved in the machine, when the slider go on top layer by layer, it actually forms the shape which you are required. After the printing process is complete, and step by step it goes down, the model goes down, and the printing layer, when the binder layer goes, it's harden the layer, harden the shape. And next step is extraction. When all printing is done, it is extracted out of the machine like this and cleaned outside. And after the cleaning, it can, you can get any shape. This method is like mostly used for printing machine parts. Any part for automobile, if you want to prepare automobile parts, if you want like an art form or anything like that, this method is the most suitable method, because it can create any kind of shape. Just you have and why it is preferred method for metals, because is that does not have centering in it. You don't have to heat the metal to becomes a liquid and then convert it in a shape in form of molds. You just have to have a powder material, powder metal, and you apply the binder uh, on top, any shape which you want, and the binder will form the shape. It has lots of advantages over conventional system in which you have to center. You also, you know that if you heat the metal, you need high temperature. It is not eco-friendly. Then after that, the properties is difficult to control, because when you heat the metal, it will change its shape, or its shape changes form, and when it will revert back to its original form, it can have the effect, and the properties can be changed. But in this case, you just have to have a like powder form, and when you put the binder, and it will get any shape. You don't have to worry about the change in the properties or anything, because it's the same material and same form. Also, the extra powder can be saved. It is also cost effective as well. So this is sometime depending upon the material which you use, polymer, or sometime you have to center it again. Sometime you have to do some post processing of painting or anything, but it can use to prepare any shape. I have few examples of these as well. In the next slides, I'll try to show. Okay, these are some of the notable supplier of 3D concrete printing throughout the world. I told you previously that supply chain is a bit limited. There are not many there are not many printer suppliers. These are a few big names: Cybe, Icon, Cobot, Wasp, Construction DD, Rosso. They have different kind of printers, gantry, robotic arm printers. They produce a lot of it. And if you have to buy a printer, you have one. Mostly, these companies are the most common one which people use, or which are like more advanced in 3D concrete printing, and they also have their specific material as well. I told you previously that concrete have strict rheological properties for 3D concrete printing. So you cannot just prepare any Igdochar or 1 to 4 or like 136 concrete and use it for the printing, because it won't work. You need a concrete which have a specific rheological properties, that it, when you mix water, it is flowable, and then when you extrude it out, it should be hardened. I'll discuss the rheology in coming slides. So for that, normal concrete cannot be used. So what happens nowadays, like most SIB in PolyU, in my USC, we have the SIB printer, and we also have the SIB cement as well. Because what generally the company suggests, that if you want to use our printer, you have to use it on our cement, because our cement has the properties which suits to the printer. Because for SIB, you have the extrusion speed is like 2000 or 3000 rpm, so it excluded very quickly, and you need a material which hardens very quickly, like 5 minutes setting time or like 10 minutes setting time. So for that, um, uh, they give their own ready mix materials in powder form. You just had to add water and use it. In research areas, we are trying to prepare our own as well, but these are the notable suppliers of the 3D printing concrete material which they have prepared. Now, I'll discuss about some applications for 3D concrete printing. Like this is the figure of general printing. If you talk about 3D printing, it's a vast field. It can use in aviation, dental, automobile construction, jewelry, prosthetic limbs, food, prototyping, clothing, sculpturing, a lot of fields. So it has like numerous applications. But if we focus on like construction, so we have currently like there are, maybe I have missed some, but generally these are the areas in which 3D concrete printing is used these days. Like printing housing, living sea walls. I have some example. I'll show it to you. Artificial coral reefs, architecture member, art and abstract design, machine parts, permanent formwork, prefabricated structure members. So this is example of 3D printing houses. You can see this one is from New Zealand. This is from Florida, Japan. So what these houses were prepared using 3D concrete printing technology, in which using the robot. You can see in this house in Japan, you can see the layer-wise construction. Actually, you can do the finishing afterwards, like in the picture from Florida, you can see. But generally, in Japan, they have tried to show it that it's 3D concrete printing. These are the application which already have been used, and already around the world there are lots of houses. I think in USA there is a project of 100 houses. I think it's with SIB or something. They have a project of preparing 100 houses using 3D concrete printing. Okay, this is artificial coral reefs. This is also like NC wall. This is also quite interesting topic for 3D concrete printing, and a lot of research is going on in this field. We know that marine life is in danger because of the climate change and the rising temperature of the sea. So what marine life is actually uh, reducing. So what happens is that modern research, they try to, and the coral reefs, the location in which the marine life prepare their home and they can grow, they are also like disturbed and they are collapsing. So scientists nowadays are trying to prepare artificial coral reefs and then put it in the ocean or in the seawater, just to use it for the manufacture of like use it to save the marine life actually. Why 3D concrete printing is important in this aspect? Because you can see the shape. This shape, if you want to prepare this shape, it is difficult for traditional concrete printing. And if you want to use this shape, you have like limited option. You have to prepare the formwork for every time, for every shape, for every marine life, every condition. It's different. They have requirement how much the opening should be, and like, so on the basis of that, if you use 3D concrete printing, it is so suitable that you can print the coral reefs in any shape, any form. Same is the concept with sea walls. Sea walls are prepared in different shapes. Actually, I forgot to add the picture. I also prepared a sea wall, which is also for the restoration of marine life, or in this different shapes they can lay their eggs, and then new communities form. Also, this the left one picture is also of our group. Like we prepare this planters, and these are like different shape, and also it can be used for any these are just example of planters, but you can prepare any shape from it. Any, like I have maybe a few more options like this. any furniture or architecture items in the parks. These days, now this stuff is quite common. They use 3D concrete printing to prepare different shapes, structure which look aesthetically very beautiful. So 3D concrete printing is also very suitable for these things, because apart from we have the shape advantage, otherwise it's very difficult. Okay, now uh, you must have heard that there is a problem with 3D concrete printing. I'm not sure how much you're aware of 3D concrete printing and the issues associated with it, but people say that using it for reinforced concrete is a big problem and it cannot be used. So there is another way of using 3D concrete printing, and it is like a very common research area these days. One of my group members is also working, is like permanent formwork. What people do nowadays, instead of printing the actual beams, they prepare printed formworks of any shape or any beams, and it is a permanent formwork. After the permanent formwork is prepared like this column, we put uh, structural steel inside, like longitudinal bar stirrups and any shape, and then we put the rest concrete. We pour the rest concrete in it. So in this, and then we don't remove the permanent formwork, which we prepare in form of 3D concrete printing. So what this does, this is kind of a hybrid approach of 3D concrete printing and structural steel, because currently the research is not evolved as such that we can prepare a reinforced concrete printed structure. So what researchers are doing are, they are preparing the formwork, and then, so what is the advantage? You get rid of formwork. You don't need any formwork for this kind of structure. You don't have to prepare any formwork. You can just prepare it using the 3D concrete printing, and then in the conventional way you put the steel and use it. So in current stage also we can use this 3D concrete printing for structural application, just using the permanent formwork. Okay, I hope you understand, and if not, we can discuss it afterwards as well, after the end of presentation. Okay, these are, I already showed you, different architecture members can be prepared in the, there are in Hong Kong, in China, Hong Kong, there are lots of uh, benches and stools. They prepare it with 3D concrete printing, architecture structures in like different parks, which can be prepared. Okay, this is example of powder-based printing. I discussed previously about powder-based printing, that we can prepare any shape with powder-based printing. It can be used as art, abstract. It can also be prepared to machine part. I think I forgot to add the machine part. I'm not sure. Yes, I have actually included it. So we can also prepare any machine part using 3D concrete printing. So it's mostly polymer based. You just have to put on the powder where you want the shape you want, you put the binder, and then you remove the excess powder, and then you can get any shape that you want. So this is example of powder based printing. And also structured parts, like I discussed, machine parts, any shape. If you want to prepare metal, use metal 3D printing, you can prepare any shape, even lightweight, any material can be prepared. And also the shapes. There is another advantage of 3D printing. If some of you people have worked on like finite element analysis, and you know the critical stress points and lots of shapes, and how the compression and tension members affect the strength. And instead of whole concrete, we can prepare it in any shape. So this is also an advantage of 3D concrete printing. Instead of preparing like concrete beam, the whole secure concrete beam, we can actually prepare a beam like that. Not the beam which is like, it is not like the conventional beam. And this beam can only be prepared using the 3D concrete printing, because you cannot just prepare a formwork for these kind of beam. And this is the customized design, structural design for specific kind of a loading. So this customization will actually improve the 3D concrete, the process of structural optimization, and based on like finite element analysis and the critical stress points you have, you can put the concrete where you need or steel where you need, and you can just remove the material where you don't need. So this is also a very important aspect of 3D concrete printing, that which not only can make the structure lightweight, safe, but also allows us customization, and using the FEM analysis, we can just use the material where we need actually. So that is another, and we can use it to prepare prefabricated beam. Actually, we don't have to do it on site also. We know about the modular construction. We just prepare a prefabricated beam in the factory based on the requirement of the structure, and just transfer it to place and then follow. Okay, I hope it will have uh, you have been inspired about the applications. I have tried to include different applications. Now we'll talk purely about the concrete part, rheological requirements about the 3D concrete printing, and what are the rheological requirements. Rheology, I'm not sure you are familiar. I hope you will be familiar with the rheology. Rheology is the when you apply uh, uh, stress to a material, the response of material flow and the applied stress is the rheology of the material. It is not like the workability and traditional stress properties. We all know that we generally what we do the setting time, we do the workability of the slump test for the concrete, and we use these fresh properties for cast concrete. But 3D concrete printing, these qualities are these fresh properties are not enough, because if we only do the setting time and we only do the slump flow test, it will not tell us whether the material which we are preparing it's printable or not. Although there is a range for flow, generally we the slump flow we it varies around like 15 to maybe 16 or 17, and also with the setting time it depends upon the printer. Or for the robotic printer it is like 5 to 10 minutes, and for like gentry we want like 1 to 2 hours setting time as well. But we also want it to be buildable or harden quickly. What happens is when the printer is the concrete is concrete is pumped, it should be workable, and then it is extruded, it should harden quickly. So for that, we have to check the rheology of the material. Uh, and in rheology, what we try to measure, three basic parameters which are important for concrete uh, to say whether it is like printable or not. One is like one is static yield strength, other is dynamic yield strength, and third one is the plastic viscosity. Static yield strength refers to the level of stress required to initiate flow in a material. If you want to make a material flow, because we are talking about the concrete slurry or mortar slurry, so we want it to be flowable. So the stress required to material to be flowable, we can measure using this. How it works, like in rheology, this is vein can be of any shape. Like most common is like this 4-step vein, but there are other veins as well. And this is the fresh mortar. What we do is like we at certain level we insert this vein in the fresh concrete, and then we apply our required program. It depends upon what specific property you want to determine, like flexurometry, pumpability, buildability, anything. So there are like different programs. You have to give the flow rate and shear rate, flow rate and time, and based on the resistance to that flow, it will give you the values of static yield strength, dynamic yield strength, or plastic viscosity. So what happens? This vein when rotate in concrete, it will apply some force on the mortar, and mortar will resist this force, and this will give us the value for the static yield strength or plastic viscosity. And based on these values, we can then decide, suggest whether the flow is like the material is printable or not. Generally, like 600 to 2400 is static yield strength, but it varies depending upon the requirement, depending upon the printing approach you are applying, and it has lot of values. So you cannot just simply say that one static yield strength is enough. And also, like, you have to check at the yield strength at different times, at the start, after 30 minutes or 1 hour, depending upon what requirement you have. So static yield strength is the stress required to initiate flow. Dynamic yield strength is minimum strength required to maintain the flow. Firstly, you all know that if you have to move something, you have to apply more force. But when a material start to moving, then you don't have to apply a lot of force. So obviously, dynamic yield strength will be little less than the static yield strength. It is important for the flowability, the pumpability, the extrudability. It depends that it should be extrudable as well. And then the last thing is plastic viscosity. It is the resistance to flow once concrete start flowing. Like, it is most important for the buildability. When the concrete start to flow, then after the flow, whether it will retain its viscosity or not. It's if it is like not a good mix and it has segregation or something like that. So obviously the viscosity will reduce after you applied force on it. Like, if you have a good mix, when you do the extruding, after the extrusion, the material will come back to its original property when you have extruded it out in layers. But if the mix is not good, after you applied the initial yield strength or initial stress, it will have a permanent change in the structure of the material. So it will be more flowable after the extrusion. So it is also important that you have to check. We check the thixotropy of the material, whether after the uh, initial force, material come back to original viscosity or not. So plastic viscosity is important in this regard. So for printing, these are the few factors which are most important. Uh, and like most of the research nowadays focus on these things. Like, step one, you all know mixing. So the mixing process, what should be the mixing speed, mixing duration, how it affects. It is one of the most important principle for rheology. Like, if you do more mixing, it can affect. You all know, I'm not sure how many have you have worked on concrete, but you know that if you mix more, then there is lots of and the material is not good, then you have lots of chances of segregation or bleeding as well. So mixing duration is very important. Mixing speed is very important. If you mix high speed, mix for high duration, it can cause bleeding or segregation. So rheology can be affected by mixing speed. Secondly is the pumping pressure, layers, layer roughness, length of pipeline. All of these are important. So if you want to do the extrusion, you do it through the pump. So the pump line is very important. If the line is too long, it can have a disadvantage. It can even hard in the lines as well. There is a lot of issues which happens like that. That sometimes the material get hardened through the pumps, and sometimes material is too flowable. So we have to be very critical about the property of the cement, which property of the mortar which you are using. Also, another step is the nozzle shape, extrusion type, extrusion dimension, nozzle dimension, anything. Like, when it goes through the pump and then it extruded out like this. So the shape of the nozzle, the speed of the extrusion, it is also important. and we have to just vary the speed based on the requirement. Sometimes we, during the extrusion process, because we are working with concrete, and you all know that concrete will harden with time. So in the start of extrusion, the concrete may not be that hardened, and you have to have a specific, maybe like 500 or 600 rpm extrusion speed. Like in, but after like 10 or 15 minutes, the concrete start to harden a bit, not set, but slightly less flowable. Then you can increase the speed of extrusion to control the layers. If it is done manually, like during printing, we have to do this. Not for like maybe the robotic system, it's not that critical. It's also critical, like very critical, but generally in a robotic system we try to follow a specific kind of cement with the specific requirement, and mostly we use the same cement, and then we have lot of less problems. But in gantry, where the extrusion speed is a bit slow, we have to be very critical with this, and we just have to observe the layers, and we just increase or decrease the extrusion speed depending upon the actual layer of that. So if flowability is not good, what are the problem which can happen during the 3D concrete printing? One is that material could be too flowable. So if you have a material which is too flowable, or it is not very strong or not very buildable, it can just collapse after the layer. You see, there are like the layers are not visible, and they are like collapsing, and they are also not stable, and they, also the shapes could be like different, like it may it could be very thick, very thin, depending upon. So this is a problem if the material is too fluid. If no interior is good, it should be like that. The layer should be like of same thickness. The layer should be like very uniform, and there should be no lateral movement in case of that. So it is a good printable mix. But sometimes it also happens that mix can, like I said, the mix can harden quickly. So if the mix get hardened, this could be the problem. Like it will not be extruded out. It will, because it's quite hard now, and because of this hardness it will not be flowable. And if it is not flowable, it cannot be extruded, and if it cannot be extruded, it will have these gaps in the layers, and this is also not a good mix in this regard. Also, in case of, these are like problem with flowability, pumpability, and printability, that it is printable or not. The other problems which are associated are the buildability and shrinkage. In 3D concrete printing, buildability is a big problem. In this case, it is too flowable, it is like not printable. In this case, it is too hard, it is not printable. But sometimes it is good, it is printable. But after certain layers, the bottom layers are not hard enough to resist the weight of the top layers. So it is not, the term we use for it is buildability. If the bottom concrete is not hard enough to take the load of the subsequent layer, it can also collapse like this. So it's very important that you have a material which hardens as quickly so that it can it can bear the load of subsequent layers. So you have to design your mix in such a way that it should be flowable. One, it should be extrudable. Two, and it should harden quickly so that it doesn't fail upon the load. But there is no hard and fast rule for this design. Actually, it depends upon what kind of printing you are doing. Like for example, if the same mix which is used to prepare this, if you use it to prepare a house with big dimensions, then the printer has a long way to go to come back to its original position. So in that time it can harden. In the small printing it might not harden, but maybe in the long printing it harden, because it will take more time. So it's not like mix you can design in isolation. It's very important that you know what you have to print in, what are you preparing the mix for. So it also depends upon the actual printing requirement as well. So if the mix harden, like the initial setting time is like 1 hour, and you do it for a big construction, then when it goes along the perimeter on the rooms, so it will take like maybe 15 or 20 minutes, and then the subsequent layer when will be placed, it will be already hardened as well. So this is an advantage of larger construction using 3D concrete printing. Actually, it is much easier than if you prepare a small model, because for small model it will come back very quickly and it will not harden as well. But the point which I am trying to make is that it is important that you have to check it, what are the requirement. And the last step is the shrinkage. Generally in 3D concrete printing, we have to use a lot of cement because it has to harden quickly, and in general it has more cement than the conventional concrete, and this is actually its disadvantage as well. But since it has a lot of cement, the reaction is high, so it has lot of chances of shrinkage as well. So you have to be a drying shrinkage as well, like, and plastic shrinkage, sorry, plastic shrinkage. So you have to be like very careful with the design as well, that it should not crack afterwards. So this is another issue. Generally we try to, there are lots of research going on, is to reduce the amount of cement, replace it with supplementary cementitious material, replace it with geopolymer or clay activated materials. Also, to use other materials like SAP or uh, VMA or anything, just to control the viscosity and reduce the shrinkage and reduce the reaction rate. Buildability is normally they use nanosilica to nanoclay to increase the buildability. So it's also, but it is a critical issue which I have discussed. Okay, uh, now you see that flowability issues, I discussed these issues in detail. So you can see that it is very generally, when we do the 3D extrusion based 3D printing, we follow a very strict kind of mixed design. A material which should be like very flowable, it should harden very quickly, and it is like very stiff kind of material. It's sometimes very difficult to attain, and then we have to be like do a compromise between the flowability and the hardening, and like we try to settle on a mix which is like very much on the edges of each boundary, that it is enough flowable, enough buildable, and enough extrudable. So instead of developing extremely strict mix, the modern result is, for especially for concrete, is also focusing on applying the two-stage printing for concrete. Two-stage printing, generally, there are like in latest research, there are like two major methodologies which are used these days. In two-stage printing, what is the difference? So after the initial mixing, transportation, concrete pumping, and concrete mixing, in this extrusion, the last point where the extrusion is happened, there we also introduce a dynamic mixer, and we use accelerator here. We use a mix which is like very flowable, very uniform, with long open time, with adequate flowable property, but it will not harden very quickly. So here what we do is we prepare a flowable mix, and then when it pumps out, here at the extrusion stage, we using alternative pump, we use an accelerated liquid. So what it happens, instead of making it enough hard at this point, we pump it, and In the extrusion stage, a dynamic mixing is done with the accelerator, and at this stage is hardened. It hardens very quickly, and after that it can be extruded. So this is called set on demand or two-stage printing. In this approach, we don't have to prepare a very hard mix or very stiff mix which have specific qualities. We can just prepare a mix which is very flowable, doesn't harden very quickly. But when we apply accelerator at the time of extrusion, with the reaction with accelerator, it will harden very quickly. So this is one approach which people follow. There are like instead of accelerator, I have few other slides in which I will show what technologies are generally used. But the basic concept of two-stage printing is that we we make the mix more buildable or more hardened at the extrusion state, not at the initial pumping state or initial mixing stage. So initial mixing stage, we prepare a mix which is very flowable, and then in the secondary mixing stage, we introduce any activator, or we introduce any accelerator which hardens the material very quickly, and in that way we can control the flowability, and we can also control the hardening of the material. Other Other option is this two-stage printing technique of twin pipe stretching. In this approach, what we do is we prepare two different mixes, and both mixes here we are connecting like it's a very small nozzle, very small pipe, and there is only accelerated liquid. All the slurry or all the motor is in this pump. In this case, we prepare like two different pumps, and same procedure. We use a cement base. In research, they have used different kind of materials as well, but for this presentation, I use a this is a cement based material. This is a limestone based material. Both are slurry, and both have like similar flow properties, because here the difference is like it is a slurry and this is a liquid. So liquid pressure and everything will be changed different, and the slurry will be different. In this case, they both are slurries, and they have like similar kind of properties, and then they have two different pumps in which they will go which will pump the concrete in the extruder. And here we have introduced a static mixer. It doesn't move, it's static mixer. It's like a spiral structure, and when concrete moves up around the spiral, it will mix automatically. Like you don't have to it this doesn't actually rotate, and it just because of the movement across this spiral form, it mixes the two slurries, and then a combined mix which is quite hardened can be prepared. So this is another approach. This approach is called twin pipe strategy, and this approach is called set on demand. So both are quite common in now 3D concrete printing, because the conventional printing has some limitations, and current research is focused on this to make a material which is quite flowable. You just have to mix it at the secondary state, and you don't have to prepare a mix which is quite hard. Uh, for two-stage printing, there are like this is the general form of two strategies which are applied. But in for hardening the mix quickly, here I have mentioned only accelerator, but here are like different technologies which are used to prepare to make to harden the mix quickly. In there can be like chemical intervention. Accelerator can be used if you are working on geopolymer, then you use activator solution. We use high concentration of sodium oxide. We use super plasticizer. We use VMA. We use HPMC. We use SAP. Like different kind of additives can be used at the print head, just to increase the yield strength and the buildability of the material. So this is a mix modification approach in case of dynamics mixing. Physical intervention can also be done, and physical intervention include like microwave heating, electromagnetic radiations, ultrasonification. So these are also approaches which are used. There are like with microwave and ultrasonic rays, there are some health issues related. So there are some limitations as well, but these can also be used like for especially, geopolymer hardens very quickly with the temperature. So if we use microwave heating approach or we use the ultrasonification approach, it can harden the material quite quickly as well. So these are also approaches which can be used or which are used for 3D concrete printing. Instead of modifying the mix, we just use an alternate approach to harden the material quickly. And the third one is the two pipe strategy, in which the static mixing is done, and it is different from that, which I have already explained. It Any approach can be used, like all these approaches can be used for two pipe as well. But here, the static mixing is done, and in the uh, set on demand, the dynamic mixing is done. Now, in the last, I have like few examples of the work which are done in our lab. My work is not yet published, so I'm not sharing my work. It's an open seminar, but these are some of published work of my friend in our group. So it is based on the intelligent real-time quality control for 3D printing concrete with nail nozzle select secondary mixing. I've discussed the secondary mixing process. That what we do is we do we at secondary stage we use some accelerator or accelerator solution to harden the material quickly. But what happens is that when you use anything, the extrusion is like a continuous process, but it can because concrete is not like a metal or any other thing that it will have a specific property. So concrete can be with time it can change its shape. It will be a bit more flowable or less. You can see in this figures that the width of the layer is fixed and then it is reducing, and here the width is more, here the width is cracking. So in actual construction, when you do the work, it can happen that you have the layer can be the extrusion layer can have different rheology. So what my friend has done is like he prepared a real-time software, machine learning based. He took like thousands of pictures of different layers, then trained his model to identify that which is like the original layer, which is like the layer is now reducing, now where layer is more thick. Why? Because if the layer is thin, we have to have increased extrusion speed. And if the layer is thick, we have to reduce extrusion speed. Because when you are extruding the material, there is a continuous movement of the flow, movement of the internal system. And then if the speed is slow, then what happens is that it will be if the material is hardened, then the flow will be not very uniform. So you have to control the speed of the extrusion as well. So what he did, he prepared a real-time software. During on the extrusion, he applied the camera. The camera will take the real-time pictures. Real-time pictures will be sent to the back software, and it will learn whether the layer is okay or not. If it is okay, then the extrusion speed will remain the normal. But if the layer is like thick or thin, it will indicate the air machine, and then the extrusion speed will be increased or decreased at the same time. You don't have to do it manually, and it will be done automatically. So this is a great example of the application of AI technology to control the thickness of the control the extrusion behavior of the extrusion of the 3D concrete printing in real time. You don't have to do it manually. You just have to have the camera which will record, and then it will automatically increase or decrease the speed. This is a second form. Like I discussed, in secondary stage, we use different methodologies, like I discussed about the accelerator or something like that. But this is another work in which we are using CO2 mixing. Instead of like using air curing, we use instead of normal mixing, we use the water to mix, but we also apply the carbon dioxide to the mixing process. Because of that carbon dioxide, the material actually hardens quickly. This is the reaction in which the calcium, carbon dioxide and water reacts, and then eventually calcium chloride is formed, and then calcium chloride is like positive charge. It attracts the CSH and integrates, and it hardens the material quickly. So to control the flow or to harden the material quickly, what we do is that we use the carbon dioxide gas. So it is more, making it more sustainable as well, because we are not only utilizing the carbon dioxide gas, and we are using it for we are embedded in concrete, and also it is improving the property and rheology of the concrete as well. So this is another research of my group. And in the last, I just want to end with this slide, that previously I showed you the picture of the construction process which we follow, and in the future what construction process we aim to follow, or is this one, that we can use the prefabrication or modular construction. We just prepare the required beams, required column in any shape we want, and use the prefabricated uh, materials. We also use advanced building materials, sophisticated. We discuss about some of it, like CO2 mixing is also an advanced material, which because we know concrete cement is associated with concrete emissions, and if we use a material which can even absorb the carbon dioxide, so it is uh, quite advantageous as well. Then we want to use a 3D printing or additive construction technology for the actual preparation of the structure. Autonomous construction, that we don't need labor for the construction, and all the construction shall be done by using the machines. Then augmented reality or visualization process too. uh, I think maybe you are all from BIM, so you know these things, how it works. Then wireless monitoring, sensing equipment in structure, and then we can also do the real-time analysis of the structure, and then if we have to do any changes, we can do that. We apply big data predictive analysis. One example I just showed you previously, that during printing we get the real pictures and we can change the extrusion speed, reduce, or so using that AI modeling we can also control the process, and then all the data can be like uh, using the real-time collaboration using cloud storage and actual things, and then integrated with the BIM. So this is the future of construction, and it is not possible without the 3D concrete printing. Uh, and that would be all from my side. I now I'll like to take your questions, but first I have to connect the audio as well. Okay, thank you for your time. I hope I haven't taken a long time. Uh, I'll try to connect the audio now.
Much, Dr. Satali. I hope you can hear us now. Um I will. There are questions in the chat box. You can answer those questions first.
Maybe I rejoin. I leave and I rejoin, and then try whether it works or not. Okay, questions are in chat box as well, so I can do it from the chat box. I'm not sure. There are mostly the muting of the mic. Okay, there are a few questions in the chat box. Uh, I'll take those questions one by one and try to answer that. Okay, any example from real world in which a civil engineering structure has been constructed through 3D printing and it's under use, like bridge building? Actually, like if you talk about a skyscraper, it is not yet constructed, but lots of bridges and lot of houses have been constructed throughout the world in almost like in every country now, in USA, in Europe, in China, because currently the problem for the building is the use of reinforcement. In case of reinforcement, because we cannot at this stage, we cannot like completely integrate the process with the reinforcement, so that right now we use like fiber reinforced structures. For a small structure, even houses, it can be prepared easily, but when you talk about the skyscrapers or structure which can take a high load, it is like not very, it is not very common right now. And lots of research is going on in this field that it shall be used for the actual structure. Normally, bridges which are made, few are made for concrete, but some are made from polymers as well. You can you can get a lot of example. Because it's now very common and lots of buildings are prepared using 3D concrete printing. So I have not, I've given few examples, but I think it's not a big problem now. You can find any structure, but you won't see lot of structured concrete because structured concrete is still in process. Okay, the second question which is written in the chat box is, uh, can we make some building to be used commercial if there's comparison of the cost? Again, it's the same question. Commercial buildings are made, the houses are made, and houses are like cost effective as well, because the in like there are like different countries, the process is different. In USA, what, or like in Europe, what happens is that there are different companies which not only prepare 3D printing concrete, they also prepare the cement which is used for 3D printing concrete. And mostly the companies claim that the cement they are using is like eco-friendly. It is not like they are using a lot of cement, is that they use a lot of the supplementary cementitious material like fly ash and slag, and it is like quite economical as well. So we don't have like to be sure an exact data, but still people claim that the house which are built with the 3D concrete is a bit cheaper, because you don't, it doesn't involve labor, and in modern world or in developed country, the labor cost is also a big cost, not like in Pakistan. So, and also, if a company already has the initial investment, they already have the printer, then they don't have to do other investments as well. So people claim that the construction cost is reduced using 3D concrete printing approach. The third question is, can you suggest some mixed design? Okay, you can contact with me. I have different mixed design with which you do in the field. I worked on the geopolymer or alkali activated material. So my own mixed design is according to that. But I have, in our practice, we have lots of different mixed designs which can use. But it is an open forum, so I cannot share the exact mixed design. If you have any discussion regarding the material part, it is actually my expertise, and you can contact with me afterwards. Okay, the next question is, can we still use it in life in situ field construction, or it just limit to controlled environment? Actually, it is previously, like if you talk about like 5 to 10 years back, it was not used in real life construction, but now there are lots of real life construction which are building using this technology. Mostly it is not done by all person. It is not like everybody is using it. I told you previously also, like they have different companies, they have their own printer, they have their own cement, and then they get the project and then they do the construction. If you go on the SIB website, you will see a lot of real world examples. They have a lot of on field, in field. They also prepare prefabricated structure. They also prepare on-site construction. So you can get a lot of examples there as well. And now in current stage, it is actually applied in on-site construction as well. There are lots of examples nowadays. Okay, other is like how we control the weight and layer thickness affect the building. Uh, Actually, the weight you have to control by the mix design. Which material, what kind of aggregate are you using? How much air entrainment you have applied? So the weight it depends upon the initial mix design. You can control the weight, but again, it depends upon the requirement. In my group, one person is also working on foam 3D printing, printable foam concrete. So she wants to prepare a lightweight concrete embedded with foam, but it should be printable as well. It's very difficult objective to achieve. The foam concrete is not very hard, and you have to have a foam bubbles in the concrete. And during the extrusion, you don't want the bubbles to get damaged as well. So it's quite complicated work, but there are some work related to this as well. And currently also my people are working as well, or other people are working on this topic as well. Regarding layer thickness, it's like you have to design it. We have different nozzle sizes, normally 20 mm, 30 mm nozzle. And for if you want to do it like for a big construction, the nozzle size can be bigger. And you have to design for 3D printing technology. There is no one fit for all solution. You cannot give a specific mix design for all kind of construction. You have to be very specific for specific requirement. So the thickness of the layer is also, it's in the hand of the person who are using the 3D concrete printing. So you can control the thickness whichever you want, but it also depends upon the mix design. My current research is regarding the geopolymer 3D printing on two-stage. I'm working on two-stage printing, but I am preparing it for alkali activated material, not the conventional cement. So make it more eco-friendly as well, and also I am using some other technologies as well. Okay. Okay, other question is like sustainability issue. Yes, the sustainability issue is associated with the material, but not with the technology itself. Technology is quite sustainable because it reduces the labor, it reduces the material, it controls everything. So technology itself is quite sustainable. But achieve a printable material, we need high amount of cement. And to control this thing, what are we doing? Two-stage printing could be an answer for that as well. Because if you do two-stage printing, you don't want initial flowable mix, initially very hardened mix. You want a mix which is like quite flowable, and then you use any accelerator or heating system or anything, it will harden. So we are trying to control the amount of cement as well. Also, there are lots of research in when cement is replaced with supplementary cementitious materials. And because of supplementary cementitious material, the content of cement is reduced. Regarding concrete, carbon dioxide, also we can use alkali activated material or LCC. It's LCC, LC3, sorry, LC3 or alkali activated material. These both of these are eco-friendly binders, which can be used and which are actually used, which actually use less amount of cement. In alkali activated material, there is no cement, and in LC3 there is only 25% of cement. Rest is clay and limestone. Uh, so LC3 is an option. Thirdly, another thing I discussed about carbon dioxide, we are actually also in cement or conventional cement system, we are also trying to add the carbon dioxide during mixing process, during curing process, just to absorb the and try to absorb the material, try to make a mix which is which actually absorb the carbon dioxide. So obviously it will become like more eco-friendly as well. What about slabs of building printed through this technology, or it is also printed or it's prefab? Currently, like 3D printing at this stage is not like very helpful in case of slabs, because you don't need any specific 3D printing technology for slabs. If you see, we just in slabs, it's kind of a um, mm, 3D printed itself, because we prepare a flowable mix and it throws and it spread out evenly. So generally in 3D printing of slab, it is not like maybe it has done somewhere, but it is more suited for like frame structures, to get a frame which has property. Generally, right now it is not used for structure members as in quite detail. So in structure members, still there are lots of work to be done, but architecture members, different shapes, it is done. One option which one of my lab mate is working for the use of structure members is using that uh, uh, what I call that uh, permanent form work system. So it is also being done. Okay. How long duration concerned 3D printing like expiry building code in Pakistan? Actually, in Pakistan, it will take a long time to actually use, because and generally around the world also, I'm not sure it is applied. It is actually cleared in a lot of codes, especially for structure requirement, because for structure there are lots of things we need to take care of, and there should be a ample amount of research before applying it actual in structures. It is used in small structures, like I have given you examples of the buildings. There are lots of structures, actual structures which are prepared like in, but it they are not like skyscrapers. You can, for a small structure, you can use 3D printing in combination, but not for actual skyscrapers as well. So the technology is still evolving. I'm thinking that maybe within like next 5 to 10 years, it will actually use. There are lots of codes. Actually, it is different. It is not like conventional concrete code cannot be applied on 3D concrete printing, because it is extrusion based printing. It is very important to understand it. And also extrusion has another property which I didn't discuss during my presentation, but when you talk about the form conventional concrete which uses formwork, you have a specific shape, and generally the properties of that concrete is same in all direction, because in it is generally the three side or four side it is covered. So the property directional property is the same, but in 3D printing there is a directional change in property as well, because when you do the extrusion, you are doing it layer by layer. So it is very important. One of the critical factor in 3D concrete printing is the cohesion of the layers. The layer, it is not only the concrete which you prepare is hard or not, it's the bond between the two consecutive layers should also be is also very important. So the bond should be important. It has direct impact on strength as well. And also when you talk about direction, so when you do the extrusion layer by layer, so so the layer side has different strength, but if you do the other direction, it has the strength can change. So we have different research going on in this direction as well. First, to improve the layer connection, and secondly to to control the properties to be same in all directions. So the same concrete code for structures cannot be applied for 3D concrete printing. There are people are developing codes for 3D concrete printing. The other day we had a seminar here in PolyU. I think Singapore is leading in this regard. Singapore is developing code for 3D concrete printing. I'm not sure about Netherlands, they have a code or not, but Netherlands has a lot of done a lot of research in 3D concrete printing. But I know this that Singapore is developing code for 3D concrete printing to be used in their construction. Okay, I think there is no more question. Sorry guys, I cannot hear you. I couldn't hear you throughout the lecture. Is there any more
Thank you so much,
question or it's over?
Dr. Rasad, for this very
Okay,
informative. And
Dr. Vakas will wrap up. Thank you.
yeah,
I'll
thank you so
mute
much,
myself.
Dr. Rasad, for having this amazing session. And thank you, everyone, for joining us in today's webinar. We will be having more such webinars soon. So please join our LinkedIn page and other social media handles for such amazing webinars, inshallah. Thank you so much for joining, everyone. I hope to see you again.
Thank you, sir. Thank you. Thank you. Take care. Thank you.